This is section 5.2, part A, verifying trigonometric identities. Your I can statements for this section. I can verify trigonometric identities, and I can determine whether the equations are identities. When you verify an identity, that means you need to prove that both sides of the equation are equal for all values of the variable for which both sides are defined. So we need to verify this. The easiest way to do this is to work on one side of the equation and just try to make it work to look like the other side, if at all possible. So the first thing you should notice is in the numerator you have a cosecant squared minus 1. Anytime you have a trig function squared and a 1, think about one of your Pythagorean identities. The Pythagorean identity that's involved in this one is cotangent squared of x plus 1 is equal to cosecant squared of x. So if we take the 1 to the other side, we know that cotangent squared of x is equal to cosecant squared of x minus 1. So instead of cosecant squared of x minus 1 in our numerator, we can change that to cotangent squared. Now we have a cotangent squared over a cosecant squared. Those aren't very nice, so we are going to try to change them both to sines and cosines to see what we get from there. Remember, cotangent is cosine over sine. Since it's cotangent squared, both of those pieces will also be squared. And we know cosecant is just the reciprocal of sine, so we can just say it's 1 over sine squared of x. Since we have a fraction over a fraction, we can flip the second one. We multiply by the reciprocal since it is division right now. Now we have a sine squared in my denominator of the first one and a sine squared in the numerator of my second one, so those are going to cancel. And we are going to get cosine squared of x over 1, or just cosine squared of x, which is what we were trying to show. There's usually more than one way to verify an identity. As long as you're going to use the correct rules, your answer will be accepted. When there are multiple fractions with different denominators in an expression, you can find a common denominator to reduce the expression to one fraction. So if we take a look, you don't always have to start on the left. Sometimes it would be easier to start on the right and then try to make it look like the left side. So let's start on the right for this one and try to make it look like the left side. Right now our denominators are cosecant x plus cotangent of x and cosecant of x minus cotangent of x. So we need to make the denominators the same. So what we're going to do is try to make the denominators the same. I'm going to multiply the first one by cosecant of x minus cotangent of x on top and bottom. And for the second fraction, we're going to multiply on top and bottom by cosecant of x plus cotangent. Now on our numerator, 1 times our quantity is just going to leave us with cosecant of x minus cotangent. Right here we have a binomial times a binomial. Cosecant times cosecant is cosecant squared. Outside will give us plus cosecant x cotangent x. Outside, that's outside, sorry, inside will be minus cosecant x cotangent x. And then negative cotangent times negative cotangent is negative cotangent squared. If we go ahead and simplify that one, we're going to see I have a positive and a negative cosecant x cotangent, so those are going to cancel. We're just going to be left with cosecant squared of x minus cotangent squared of x as our denominator. So the denominator on the other side will also be cosecant squared of x minus cotangent squared of x, because we are just multiplying the same binomials. Now our numerator in that case, 1 times cosecant plus cotangent, will just be cosecant plus cotangent. Now I have cosecant squared minus cotangent squared. Again, this is making me think about one of my Pythagorean identities. If we look back at our previous example, we know that cotangent squared of x plus 1 is equal to cosecant squared. So if I take that cotangent to the other side, we know that cosecant squared minus cotangent squared is actually equal to 1. So we can change those denominators to 1. The denominator's the same, so we can just add our numerators. Since the denominators are 1, those can basically go away. So we're left with cosecant of x minus cotangent of x plus cotangent of x minus plus cotangent of x. The first one is cosecant. Now if you notice, we have a negative cotangent and a positive cotangent, so those are just going to cancel. I have a cosecant and a cosecant, so that means I have 2 of them. So we're left with 2 cosecant of x, which is what we were trying to show. When you are trying to verify, if you need to eliminate a fraction in which the denominator is in the form of 1 plus or minus u or u plus or minus 1, remember you can always multiply the numerator and the denominator by the conjugate of the denominator. So if we take a look, it's always easier to start with a fraction and try to get rid of the fraction than it is to build a fraction. So let's start on the left side, try to make it look like the right side. Now we need to get that subtraction out of the denominator. To do this, we're going to multiply by the conjugate. And the conjugate is the same values, just the opposite sign. So I'm going to have 1 plus the cosine of alpha instead. In the numerator, that's just going to leave me with sine of alpha times 1 plus the cosine of alpha. In the denominator, we have a binomial times a binomial again. So if we FOIL, first gives me 1, outside, inside, and last. If you notice, we have a positive and a negative cosine, so those are just going to cancel. So I'm left with 1 minus cosine squared of alpha. Now let's think back to our Pythagorean identities. We know that sine squared of x plus cosine squared of x is equal to 1. If we rearrange this and take the cosine to the other side, we know that sine squared of x is equal to 1 minus cosine squared. So in our denominator, instead of 1 minus cosine alpha, we can just change that to sine squared alpha. Now we have a sine on top and a sine squared on bottom. So I can cancel this sine with one of these. When you have a fraction, as long as the denominator is just one value and the numerator is addition or subtraction, we can break it apart into 2 different fractions. So I can say 1 over the sine of alpha minus the cosine of alpha over the sine of alpha. 1 over sine, the reciprocal of sine, is cosecant, and cosine over sine is cotangent. And this was a plus sign that I magically changed to a minus sign somewhere in my problem. So we are left with cosecant of theta plus cotangent of theta.